Well, hey folks, this is Dr. Duncan with your BI 101 instructor, and this is going to be part 4 of our Unit 5, which is on climate and biomes and how the climate affects biodiversity. And our next step is to talk. We're in the process of talking about anomalies to the Earth's climate patterns, the things that cause deviations from the predicted patterns that we would have across the planet. Those predictions based on this model right here that would predict tidy bands of desert and high rainfall across the planet. So we've talked about currents and the influence of currents on land masses. In particular, we use the example of the Gulf of Mexico. What I want to talk about next is monsoons. Now, we typically associate the term monsoon with Southeast Asia and other parts of South Asia. However, monsoons are found in other places of the world. There's a southwestern U.S. monsoon in the summer, and we get a partial monsoon here in the southeast, or at least something similar to a monsoon. Climatologists might disagree with the application of the term. What happens is that during our summers, an effect like a monsoon effect brings a lot of rain into Alabama and the rest of the southeast during the months of June through September. And this shows up in the afternoon thunderstorms that are so typical of our region. And here's how the summer monsoon works. Remember how I explained that the bodies of water are very sluggish to change temperature. They're very lazy, if you will. In the summertime, especially in the early summertime, what will happen is that actually not just during the early summertime, but all during the summer, what happens is that the Gulf of Mexico will heat up, but it'll stay more of a constant temperature compared to the surrounding land masses and the air above those land masses. And what will happen is that early in the morning, when the sun comes up, the sun starts irradiating the land surface. The land surface heats up. That heat then radiates into the lower atmosphere, heating up the atmosphere, and that warm air starts to rise. Well, we can't have a vacuum left behind. Instead, air from the surrounding regions are brought in because most of the other land in the surrounding area is causing air to rise. That creates a general tug of air that's over the Gulf of Mexico. So we start pulling in air surface winds from the Gulf of Mexico. Now the Gulf of Mexico all night long has been nice and warm, and water vapor has been accumulating in the lower atmosphere over the Gulf. So it's very moist air that comes in at this point. And what will happen is that this warm, moist air will get pulled in over the land, and then it becomes even hotter. That air goes from being warm to hot. And as it heats up, it rises, and now you've got warm, hot air rising, and of course that leads first to cloud formation, and over the course of the morning it leads to thunderstorms, and we get thunderstorms around late morning and in through the afternoon in most places of the southeast. So that's the summer monsoon effect, and that's a really important effect that happens to influence the rainfall patterns in Alabama. That's why Mobile and Baldwin County get so much more rainfall than the surrounding regions. However, this effect is also happening on a broader scale throughout the southeast all summer long, so it's not just the immediate coast that's affected. So to complete the picture of what a monsoon is about, this is a diagram that illustrates what you would have with a winter monsoon. And in places like Southeast Asia, what happens is that this whole the dynamic flips around, and because the water body is now retaining heat in the winter, and it's a source of heat, and the land has cooled down, you wind up having the reverse happening, where you get wind from the land sweeping across the surface, going out over the ocean. If it's Southeast Asia, it'd be like the Indian Ocean and the Indo-Pacific, and then that warm, moist air rises up and over the ocean and rains a lot. So what happens in Southeast Asia is you get a lot of rain out over the oceans at this point. We don't get this in Alabama because we're too far north, and instead we get the effect of these cold fronts that move in. And typically starting around mid-fall through late spring, you can feel these fronts move through roughly on a weekly basis. And what you get is a very different dynamic, a different climate pattern that does bring a lot of rainfall to the southeast. In fact, those are our rainiest months. Even though we got that summer monsoon effect, we also get these as being our rainiest months. Most years are our rainiest months of the year. I'll let you study this on your own, and I think the textbook has a summary of cold fronts and how they work. But it's basically high pressure air that's dry and stable moving in from the polar regions and shoving warm, unstable air that's in its path out of the way. And out of the way includes upwards. And when that warm air gets shoved upwards, it causes those convection storms, those thunderstorms or rainstorms, and that's when we get all that rain associated with fronts. Okay, another anomaly that affects the regional weather patterns are rain shadows. I'm not going to spend a lot of time on this. It's covered in your textbook. But essentially what's happening is that surface winds are carrying moisture-laden air onto the land. It hits a mountain range. The mountain acts like a wedge and forces it up, and that forced upward momentum causes that air to cool because it's going to higher altitudes, and as that air cools, it loses its ability to hold water vapor, and that water vapor comes out of its gaseous form and turns into liquid water, which then rains down on the landscape. That air continues to move to the other side of the mountain ranges, but now it's dry. And so this is why on the Pacific coast you have moist conditions on your mountain ranges close to the ocean, and on the other side you've got dry conditions. In Alabama, our mountains are not tall enough to cause a rain shadow effect that's very dramatic, but we do get a slight one up in around our highest mountains in the northeastern corner of the state. It's subtle, but on most days when rain's moving through the region, you'll get a little bit more rain on the side that's facing where those fronts are coming through. Okay, so this is one of those other anomalies to regional weather patterns. A fourth one here is the altitudinal ecosystem gradient that we've talked about before, but that you go without having to travel far on the map. You can go upwards in altitude and see a change in the temperature and rainfall, and therefore what ecosystems are found. And it's very similar to what you find with the altitudinal gradient. It's the same thing that is very similar to what you find with a latitudinal gradient when you're traveling from higher latitudes, like at the poles, towards lower latitudes at the equator. Okay, so we'll wrap this up with this question, which is, what is the role of climate in shaping Alabama's high biodiversity rankings? Recall that Alabama is number 5 in the U.S. for total biodiversity. And if you look at this map, you see the adjacent states to Alabama and their rankings for biodiversity, and you see that there's a lot of variation. Alabama and Mississippi are essentially mirror images of one another, and yet Mississippi has a ranking of 17. Louisiana is 18, South Carolina 14. Georgia, right next door to Alabama, is number 6. Now, all 5 of these states that I'm focusing on here have very similar climates. It's very moist and it's very hot. So if climate was the biggest of drivers in terms of shaping our high levels of biodiversity in Alabama, we would expect that all these states would have very similar numbers, but clearly they do not. So there must be other factors influencing Alabama's biodiversity, and indeed there are. And as we'll talk about in the next couple of weeks, the major factor that we're going to be focusing on is geology and the role of geology in influencing biodiversity levels in the southeast. So I'll end there. There's a couple. I think there's a couple extra slides on the PowerPoint on it's posted on Moodle that you can use to supplement and help further understand those materials that we cover there. So this is the end of Unit 5, Climate and Biomes and the influence of climate on biodiversity.